In this section, we want to learn about solving systems of linear equations. Systems of linear equations consist of more than one linear equations. Solving systems of linear equations means we have to find out the solutions that satisfies each of the linear equations in the system. As a warm-up, let's consider the graph of y equals x plus 3. If we put x equals 1 and y equals 4, then y equals 4 and x equals 1. And so this is a true statement. That means this one is one of the solutions. For this linear equation. However, if we put -1 and 4, then left side is y equals 4 and right side is -1 plus 3, which is 2. So those are not equal. So that is not equal, so that is false. That means this is not a solution. That implies whatever the points on this straight line is, all of those points are the solution set of this linear equation. Let's do the first problem. The first problem is for each ordered pair, determine whether it is a solution to the system of the equations. I said solving systems of linear equations means when you put the coordinates, given coordinates, that must satisfy both linear equations. For example, if you put -3 and 1 to the first equation, then this is the first equation, this is the second equation. Then for the first equation, y equals 1, and right side is -2 times x value is -3, -5, which is 6 minus 5, which is 1. That is true. Let's apply -3 for x and 1 for y to the second equation. Then we have 6 times -3 plus 3 times y plus 1. Then that's -18 plus 3 equals -15. So that's the same as the number that appears on the right side. So that is true. So we verified that -3 and 1 is one of the points of the graph for the first and second equation. That means this coordinate satisfies both equation. So the answer is a yes. For the second case, we can do the same. We have 5 and 0. If you put that in the first equation, then y value must be 0 and x value must be 5. So -2 times 5 minus 5. That is -10 minus 15 equals -15. -5 equals -15. So those are not the same, so that is false. So what we verified is 5 and 0 is not in the first straight line. So that cannot be the solution for both systems. So we don't have to verify the second one. You do the same thing for the third and fourth case, and then you can verify the third is no and fourth is yes. Let's suppose that we have a system of linear equations that has one or more solutions. Then the system is called consistent system. There are two cases. One has different slope, then definitely those two linear lines must meet at one point. If they have the same slope, then and pass one common point, then two lines are identical. So those are two equivalent equations. When that happens, we say the system is consistent system. There is a case that the linear system doesn't have a solution. Then the system is called inconsistent system. What is the case? When we represent the system of equations with slope-intercept form or point-slope form, the slope of two equations must be the same, but they don't pass the common point. Then that'll create two parallel lines and they will never meet. So there is no solution for a system of linear equations. In that case, we say that the system is inconsistent system. The next definition is if two equations represent the same line. So we are talking about this case. Then all points along the line are solutions to the system of the equation. In such a case, the equation are said to be dependent. So when we think about the equation, when we fix it to slope-intercept form, then those must be the same equation. So those are just dependent, and there are infinitely many solutions. So when we consider the system of linear equations, they have either one solution or infinitely many solutions, or no solution. When the given equations create parallel lines, when we draw those equations are said to be independent because there is no common point. This is the summary of what I explained. In this problem, we have to figure out the terminology that describes the system of linear equations. In this case, we can see two parallel lines because by looking at the lines and also by looking at the equations, those slopes are the same. But they don't pass any common point because their y-intercepts are different. So we have to say that those are inconsistent. And in this case, they never meet, so there is no solution. In the next example, we can see only one straight line, even if two linear equations are given. You can easily see if you change the expression, then the second one can be written as the first one. So they are essentially the identical equations. In this case, the system of equations is called consistent and dependent equation. What we draw in this line is based on the two linear equations. So, but they are overlapped each other. So all the points on this straight line satisfy both equations. So there are infinitely many solutions. In the next linear system of linear equations, we have two equations. The first equation's slope is -1, and second equation's slope is -1/2. When their slopes are different, they meet at one point, and that point is a solution. In that case, we say the system of equations is consistent and independent. And there is a unique solution because they meet at one point, and that is -1 and 3. In this problem, we want to graph the system and write its solution. Let's figure out how the graph look like. The first one is slope-intercept form. Slope is -2/1, and y-intercept is 3. So we mark a 3 here, and slope is -2/1. So it passes 0 and 3, and this one is y change, and this one is x change. So we add 1 to the first coordinate, and then it becomes 1. And when we subtract -2 to the second coordinate, we have 1. So it should pass 1 and 1 here. After we mark and join with the straight line, then we get this green colored straight line. For the second linear equation, we have negative 4x minus 2y equals minus 2. We don't like minus, and also we notice that each coefficient and constant term are even number. So we want to simplify by multiplying by negative 1/2. Then it'll be 2x plus y equals 1. So when we solve for y, that is y equals 1 minus 2x, we can rewrite it as y equals negative 2x plus 1. So what is the slope? Slope is negative 2, the same with the first one, but y-intercept is 1, so that's different. So we mark at the y-intercept that is 0 and 1. And we know the slope is the same, so we just draw the parallel line. What we notice from here is they have the same slope and their y-intercept are different. So they are parallel and they will never meet. So there is no solution. Let me remind you this again. If two linear systems have the same slope, then there are two possibilities. Those are either parallel or identical. Two lines are parallel, then they will never meet. So that means there is no solution. If they overlap each other, so they are identical, then they have infinitely many solutions.